So yesterday we left off with displacement. Now we're going to talk about average velocity. So whenever the average velocity is to be calculated, under any circumstance, it must be done using the formula v bar equals d over t. And the displacement has to be calculated from the VT graph using the area under the curve technique that we learned yesterday. So if you are asked to find average velocity, you must first do the area thing that we did yesterday and then simply divide by the time. Okay, so here's an example. The average velocity for time intervals A and B, which would be up to 5 seconds, so we're talking about all of that area there, right, would be the area of A plus the area of B. Yesterday we did this. We took 1/2. The base was 2. The height is 4. 2 times 4 is 8. Divided by 2 is 4. So my area of the triangle here is 4. The rectangle is from 2 to 5. That's a base of 3 to a height of 4. 3 times 4 is 12. 4 plus 12 is 16. And then the average velocity is 16 divided by 5, or 3.2. Okay? You will notice here that you cannot, and I will get some kids who want to do this. I get kids that will say, well, it's 0, and then it's 4, and then it's minus 3, and then they take the average of those. You cannot do that. Okay? Because it's also 1 and 2 and 3, and then it's 4 and 4 and 4 and 4 and 4 and 4, and then it's 2, and then it's 1, and then it's minus 1. It's all those other ones. So you can't do that. You have to take the total area. Remembering that when you've got the area below that, it's what? Negative. And I would really encourage you to sort of shade it in like that so that you get that idea, that visual idea. Every once in a while I see kids that want to do this kind of stuff. They shade in down here, and that is wrong.
We can't fit it with all the picture.
Thanks, Bryce. Okay, now how many clicker questions do I have left? I've only got 3. You know what, I'm just in the interest of time so that you guys can get to that meeting, what I would like you to do is I would like you to determine the average velocity for the entire trip. It shouldn't be, because you should already have all the individual displacements figured out. Okay? Well, refigure it out, divide by the time. Go. The correct answer is 0.4. 0.4. Okay, so how do you do that? You have to add them all up. Add up all the displacements. Who got 0.4? Who got it right? Hey? Okay, you have to add up all the displacements, divide by the time. Moving on. Okay. Listen, we're going to run out of time, you guys. And then you're not going to know what's going on tomorrow. Listen. I know, that's why I got to get through everything. Instantaneous velocity is easy. You simply read it directly off the VT graph. It's a graph of velocity, so you just read it off the graph. So, instantaneous velocity at 6 seconds, right? 6 seconds is right there. The velocity is 2. I'm asking you, what's the velocity at 13? Go. Correct answer is -1. It's right there. Whoa. Right there. Right there. -1. It's a graph of velocity. Okay. Last one. Last one. Instantaneous acceleration is the same way that we did instantaneous velocity off position time graphs. In other words, we find the slope. Find the slope. Find the slope. Okay? You may need to draw a tangent line if the graph is curved. So in other words, the same one we've been dealing with the entire book. I'm asking you for the instantaneous acceleration. Instantaneous acceleration at 6 seconds, right there. Okay? Because it's a VT graph, we're finding acceleration. We are finding the slope. Because it's a straight line, we just pick the endpoints and find the slope, right? I go down from 4 to -3, down 7, from 5 to 8.5. So what's that? 3.5. So it's -2. The slope is -2. I'm asking you to find the instantaneous acceleration at t is equal to 12 seconds. Go.
The tangent line is one on the curve that
Okay, which graph? They did it in the wrong one.
Same. Answer is 1. Answer is 1, right? It goes, we're looking for the slope. It goes up 3 and over 3. 3 over 3 is equal to what? Okay.
Why is it negative because it's slowing
It's
down?
positive. Now, you know what? Here's a really good question, you guys. The question is, how come it's positive when it's slowing down? Really good question. Okay? The slope is positive 1. That's correct. It is positive 1. But how can it be slowing down if the slope is positive? Because the velocity is negative. And when the signs are opposite, if I've got a negative velocity, which means I'm moving to the left, and my acceleration is to the right, right? I'm going this way, but my acceleration is that way, then I slow down. If the signs are opposite, it's slowing down.
So it's kind of like going in reverse and
If the signs are opposite, it's slowing down. I'll let you think about that for a minute. Okay, the next 2 pages are vital important. Okay, they are so important I hand them back out to my grade 12s. Okay, so I'd like you to open that up, and if you could, don't have your booklet folded. Have it flat like this. Okay, have it flat like this. Katie Nolan, listen. Okay, you'll notice that there's 2 columns. The top of the left-hand one says position time. Does it say the same thing on the next page?
Yeah.
Okay, so imagine this page is just simply below, so it's 2 columns.
What?
This page is below, it's 1 column, and then the second column.
It looks like that.
It's like that, just like Howard just did. That's how it looks, okay? All right, so
I was thinking it was
if, what I would recommend you do is I would circle that like that, circle that like that. When you're doing any question that involves a graph, step number 1 is always identify what kind of graph it is. Is it a position time or is it a velocity time? Okay, and here's all the rules. Everything you need to know is on this page. If it's a position time graph and you're asked to find displacement, you simply read the positions off the graph and subtract. So what I'm talking about there is
initial minus time.
this kind of thing, right? Initial, final, and subtract the 2. Katie, you need to watch. Average velocity. On a position time line graph, if it's a straight line, you simply find the slope. If it's a curved line, and you're asked for average velocity, you draw a line between the points and find the slope. I highly recommend you draw those pictures in there. It will give you a visual clue as to what to do. It will. Do it.
What?
Draw those pictures in there.
I did.
Well, good. If you have a position time graph and you're asked to find instantaneous velocity and it's a straight line, we're talking about the slope at an instant. If it's a straight line, though, what do? Just find the slope, right? The slope there is the same as the slope there and there and there and of the whole thing. It's a straight line. The slope remains the same. If you're asked to find instantaneous velocity from a position time graph and it's a curved line, if I need to know the slope right there, that is the tangent line thing. Draw that picture. You find the slope of the tangent line. Find this.
Everyone's answers be a little bit.
You will get a little bit, yeah. Yeah, but that's okay. As long as you show me the process, I'm good. Okay? All right, go to the next page. Still under position time column, Matt. Pay attention. This is the important part of the day. If you're on a position time graph and I ask you for average acceleration, you can't do it. You have to first construct a VT graph. Right?
Are
You
you gonna make
can't.
that like a trick question like that?
Perhaps.
So if you ask that,
Yes,
it
I'm
can't be done, and if someone tries to do it, then you know it's wrong.
You need a velocity time graph before you can find acceleration, and the same thing with instantaneous acceleration. You need a VT graph to get acceleration. All right? Now that's sort of that last booklet that we did. This booklet has all been about velocity time graphs. So go back to the first page, column 2. Velocity time. Okay? Even if they call us down, I still need to get through this. Okay? So just listen. Displacement. If you're asked to find displacement, you are to find the area. Displacement on a velocity time graph is the area, remembering that above is positive and below is negative. If they ask you to find average velocity, then you have to
What?
Whoa, you screwed it up.
Then you have to take displacement over time using the displacement as the area. Okay, so if you're asked average velocity, you have to find displacement first and divide by the time. If you're asked to find instantaneous velocity, well, that's easy because you simply read it off the graph. It's a graph of velocity. Instantaneous velocity is easy. Read it off the graph.
So you just do it like normally.
Read it off the graph. Read it off the graph. Next page, column 2. If you have a velocity time graph and you're asked to find average acceleration, and it's a straight line, average acceleration means the slope between those 2 points. Find the slope of the line. It's easy. If it's a curved line and you're asked to find average acceleration, emphasis on average, you draw a line between the 2 points and find the slope. If you have a velocity time graph and you're asked to find instantaneous acceleration and it's a straight line, find the slope of the line, because you're asked to find the slope at a single point. You find the slope of the line. If it's a curved line graph and you're asked to find instantaneous acceleration, I need to know the slope at a single point. That's when you draw the tangent line.
Okay. JV girls, please be excused from class.
When you're doing, what you're going to do the rest of this period and tomorrow, is when you're doing all of these graphs, all of these are velocity time graphs, how to do it is always going to be shown in column number 2. If you ask for help, I'm going to direct you to that page. Kish, stop making noise. Okay? So,
This is due for
you have the rest of this period to work. You have tomorrow's period to work. Tomorrow there's a hand-in assignment that you're going to get tomorrow. If you're not here tomorrow, you need to come see me to get it today. Okay?
Today, can I have it?
So we should do
Yes.
that from now.
Do this first. Do this first.